Hi, I'm Cliff, N4CCB. In this video, I'm going to tell you everything you need to know to get started with amateur radio's digital modes. Now, I'm going to go over the concepts, the hardware, going to answer the questions of why digital, what is digital, what's in it for QRP operators, and then we're going to talk about some of the issues you have to solve and the hardware that's required to do that. Now, the cabling and the hardware are the same for all digital modes. And so this video is going to cover that, but it's going to stop before we actually transmit digital. I'm going to make a separate set of in-depth videos to cover some of the most common digital modes like RTTY or radio teletype, PSK31, JT65, and I'm even going to show you how you can use your HF radio to send email from out in the field without internet access using Winlink. So let's get started. Why digital? Well, a lot of reasons. Because it's fun, because it's interesting, because it's something different for our little bag of tricks, but maybe most importantly to me, because digital modes tend to favor QRP operation. Well, how's that? How is it possible that digital modes are of a benefit to the QRP guys? Well, if you saw my video called The Case for Morse Code, you might remember that I told you that CW uses more concentrated energy compared to the wider bandwidth voice modes. And so the signal just goes farther. And digital's like that. The digital modes tend to use a narrow bandwidth of focused energy, and so your QRP signal will go farther. Plus, there are other modes like JT65 that use forward error correction through data redundancy. So even if some of the data doesn't get through in your transmission, the message can still make it, which is pretty cool. What do we mean by digital modes, and how does that work? Well, in a nutshell, digital modes allow a ham radio operator to connect their computer to the radio. And by doing that, we can send text-based messages to each other and even pictures. As far as how it works, data on a computer, whether it's text or images, gets converted into numbers. And then those numbers are modulated or converted into sound. And that sound is sent to the radio through an audio cable where it's transmitted over the air just as if you'd pressed the mic button and made some kind of funny data sound with your voice. On the receiving side, somebody who's listening, their radio takes the sound in, sends it to the audio input of the computer, where the computer can then demodulate, convert the sound back into numbers, and those numbers are then used to display the message that was originally sent. All right, so what hardware is required in order to do this? Well, really only three things, two of which you've probably already got: a radio, a computer, and the proper audio cables. So we're going to take these one at a time and talk about some issues along the way. So the first thing you need is a radio. Well, okay, it's got to be a radio capable of transmitting single sideband. A CW-only radio can't be used for digital because when the digital data is modulated, it gets converted into sound that is sent over the airwaves, whereas a Morse code radio can only send an unmodulated carrier. So we need single sideband capability for our radio. As far as computers go, any computer that's been made in the last 10 years is fine. You don't need a lot of horsepower. So any PC is great. Macs work too. All of the digital modes have software that's written for Windows PCs. But all of the main digital modes have native applications for Macs. You might find something like Winlink where it's a very specific mode and the software is only available for Windows. Now, if you're a Mac person and you want to be able to run Windows applications on your Mac, you've got a few choices. You can bite the bullet and just buy a cheap PC to use for your ham hobby. Now, I realize that might make some of you queasy. So if you don't like that idea, you could always use Boot Camp, which means that at system startup time, you can choose whether to boot OS X or boot with Windows. And if that makes you feel queasy, there's always virtual machine software like Parallels or VMware Fusion. Doing that lets you launch Windows as though you were launching a Mac application so that you can run Windows alongside the rest of your OS X applications. Okay, so the third thing, we've got radio covered, computer covered. Now we've got to route the audio between the radio and the computer, between the computer and the radio, and we also have to solve another problem, which is how to get the computer to key the push-to-talk button to send the data through the radio, how to key the radio. All right, so let's go through that. We're going to need two cables, at least two cables. Let's say that we're talking on the radio side first, so let's address that first. We've got to have a way to get the audio out of the radio and into the computer for decoding. So that's going to take a cable. Well, on the radio side, every radio's got a headphone jack. So that's the logical place to get data, to get the audio out of a radio. We can come out of the headphone jack. Some radios have a data jack on the back of them that has a multi-pin jack, usually like some kind of DIN plug, DIN jack. And there are a number of signals that are present there, like ground and push to talk and audio in, audio out, and so on. So if your radio has a data jack, we might be able to get audio in and out and push to talk from that one jack. But we're just trying to solve how to get the audio out of the radio at this point, and headphone jack will work fine if that's all you've got. The other side of that cable, the side that has to get that audio signal into your computer probably has a mic input jack or a line in jack. If you don't, some computers, especially laptops, will have a headphone jack that actually supports 4 conductors, with the 4th conductor being audio in. Now this works for headsets. You'll find headsets used for Skype and that kind of thing, voice over IP applications, that has a little 3.5 millimeter jack with 4 tip ring sleeve. So it's possible that your laptop actually doesn't have a mic input, but that the headphone jack will allow audio input. All right, if you don't have a computer that has any kind of input, it's still not a problem, because you can purchase an external sound card such as the Signalink or a West Mountain Radio Rig Blaster, and that will handle all of your audio input and output just by going through the USB port on your computer. Okay, so that's the first cable we need, a way to get the radio's audio into the computer. We need a way to take the computer-generated audio, the modulated sound, and send that to the radio for transmission out into the world. So that's a separate cable. Well, every computer's got a headphone jack. So you can just get the data straight from the headphone jack, get the audio straight from the headphone jack, and send that to the radio. Now, on the radio side, every radio's got a mic jack. So the most logical and common way to get the audio into the radio is through the input pin on the mic jack. Radios that have a data jack on the back will often have an audio in pin on that. So either way, microphone jack or the data jack, if you've got one, that'll work. All right, now this leads us to the push-to-talk problem. We'll call it push-to-talk problem. With a microphone, you key the mic and you start talking, and as long as you're holding the push-to-talk button in, your radio's flipped into transmit mode. Anything you say is going to go out into the world. When you let go, you're out of transmit mode, back to receive mode. Well, how is the computer going to push that button? I think we could all agree that the most awesome solution would be some kind of computer-controlled robot finger that would push that button, but that's not going to happen. There are other alternatives, and the simplest way is to put your radio in Vox mode. Vox, voice-operated transmit, means that the Vox circuitry in your radio detects the presence of audio, you speaking, and it immediately flips the radio back over into transmit mode. So while you're talking, everything you're saying is going out over the world. When you quit talking, after some variable hang time, delay period, it switches back to receive mode. And you hear hams on the radio using that all the time. If you want to be hands-free, you can go into Vox mode. Now, you also have to worry about coughing or people talking to you in the background or any kind of audio that might trigger that. And there are controls that let you set the Vox gain and anti-Vox so that things like the speaker audio doesn't trip the Vox and cause a feedback loop. But using Vox is a very reasonable way for digital, because that way when the computer sends audio down, the radio detects it as if you had spoken and it sends it out over the airwaves. There's another way, and it's a little bit technical, but if you saw my video called Building a Computer to CW Interface, you saw a little circuit that I built, which allowed you to transmit Morse code by keying your radio. You can build a little circuit like that and then configure the digital mode software to set the DTR or RTS pins of the serial port whenever it's ready to transmit. And then you can connect the other end of that cable to the microphone jack's push-to-talk button, or push-to-talk pin, or the data jack's push-to-talk pin in the back, so that your digital mode software, when it's ready to transmit, can set that pin, which will cause the radio to go into transmit mode, and then the data can be sent after that. Now, the Vox solution is much simpler, right? The COM port pin thing sounds like work. All right, so you don't have to make your own audio cables. You can buy a Signalink box or a Rig Blaster, and these are generic boxes for which you order the cables for your radio. So they'll send you the box and they'll send you the cables that are for your specific model of radio. And by the way, if you've got multiple radios, you can just buy other cables so you can use the same box for multiple radios. A Signalink box or a Rig Blaster solves the cabling and push-to-talk issues for you because it's already built in for you. You don't have to do anything. So I highly recommend that you, unless you're just really ambitious or on a tight budget, spend $110, $20, whatever this is, just a little over $100, and get one of these. Now, I'm very familiar with this. I've got a couple of these. And I want to now talk about this solution and how it works. And I've got a couple of radios here that use a different way of connecting to this so that I can show you. And I've got to put up some things on the screen for you to see while I'm talking. Well, if we look at the back of the Signalink box, there's a USB jack here, and standard USB cable is going to plug into the box and then plug into your computer. And that's how audio is going to get into and out of your computer from this. Once we have a Signalink box, we no longer have to make a cable or have to have a cable that goes from the radio to the computer. This is the middleman, and now the cable goes from the radio to the box. And getting data from the box to your computer and back is the job of the USB cable. The other significant jack on the back of this is this RJ45 jack that's labeled radio. Now there are 8 pins in an RJ45, and what Signalink has done is they've taken these 8 pins and they've routed them internally to this jumper block. And if you look at that, on the right side of the jumper block, these pins go to the right side, and with the cables that are running from the radio to the RJ45, those pins are now exposed on the right side of the jumper block. And then we can use little jumper wires to take the signals from the right side of the jumper block and route them to the proper pin on the left side so that the Signalink and therefore your computer can process those signals. So, in other words, instead of making a lot of custom Signalink boxes, they've made it so that you just have one size fits all box that takes all the pins that are necessary from your radio, hooks them up to one side of this jumper block so that you can easily route the signals to the proper places so that that audio data and push-to-talk can be processed. So it's pretty clever, and it works great. Now, let's take a concrete example here. This is a Yaesu FT817 ND. I've got the 857. I've also got the 897. All 3 of these radios have the same 6-pin mini DIN jack on the back of it, and I'll show you a picture here. But with the data jack back here, I can take this one cable and plug the 6-pin DIN onto the back of this. The other end has RJ45, and that plugs into the radio jack. Having done that, we look up on the Tigertronics Signalink chart to find this radio to see how the little jumper block needs to be configured. And I'll put that up on the screen so you can see it. So we've got audio in and out, push to talk and ground all being jumpered, and it works great with this one cable plus the USB cable. The Elecraft KX3 works a little differently. Unlike the FT817, the KX3 doesn't have a data jack that contains audio in and out and ground and push to talk. Instead, the way the Signalink works with that is when you buy the Signalink for the KX3, it comes with these KX3 cables which take the audio from the computer and send it into the microphone jack. So, wrong cable. So what you see then is the RJ45 on one end that plugs into the Signalink box. The other end has a 4-conductor 3.5mm plug that plugs into the microphone jack of the KX3. Now, the mic on the KX3 it's not a speaker mic. There's no speaker, there's no audio signal in the mic jack. So what you have to do for the KX3 is you have to use the second cable that they send you, which plugs into the headphone jack. And the other end of that goes into the speaker input jack on the back of the Signalink. So if we take a look at the wiring diagram, the jumper diagram for the KX3, you'll see that from the RJ45 we're getting the microphone in and ground and push to talk. You'll notice that there's not a fourth wire there for the speaker. That's because we connected the speaker directly into the speaker input jack on the back of the Signalink, so we don't have to jump or anything. It's just a direct connection. So we're getting the audio from that. So that's an example of how two of these radios can use the same Signalink box and handle getting audio to and from the computer and push to talk. Let's take a look at the front of this real quick. The front of the Signalink has a red power button and a green LED that lights up when the power is applied. There's a red push to talk button, or excuse me, LED that lights up whenever the radio's in transmit mode. And then we have three knobs. The TX or transmit knob controls the level of the audio that's being sent to the radio, the transmission level. The RX receive knob controls the volume of the audio that's going between the radio into the computer, so that we can adjust this to get more signal into our digital mode software to make sure that we can decode it. Finally, delay, DLY. This controls the hang time, or how much time the push-to-talk circuit stays open after we've transmitted data. Now, for something like PSK31 or any kind of like packet-based, digital mode like Winlink would be a good example. We want this to be counterclockwise and be short, so that as soon as we send a block of data, it flips back over into receive mode so that we can get data from the other side. If we're doing something like sending Morse code, where we don't want it to be constantly flipping back and forth, we can set the delay longer if we want, so that the push-to-talk stays engaged, and we can just keep typing on our keyboards and having Morse code being sent without it flipping back over to receive and so on. So that's all there is to that. Now, last thing I want to talk about, and this is really critical, the volume levels are important. You can't just hook everything up and say, okay, it's going to work, it's fine. Instead, you have to, as part of the configuration, make sure that the audio being sent to the radio isn't too strong, but that it's strong enough. And likewise, the audio that we're sending to the computer, we don't want it to be too strong and be distorted or clipped, so that we have a hard time decoding that with our software. And we don't want it to be too light. So let's talk about that briefly for a minute, and then I promise you that's all we're going to talk about in this video. If we're sending audio to the radio to be transmitted, and we don't have enough signal going to the radio, it's not very efficient. It's like we're whispering into the radio instead of talking in a clear, reasonably loud voice. If we're just whispering into the radio, we're leaving our money on the table, right? We're not getting the full bang for our buck. As QRP operators, we really care about having a good signal-to-noise ratio. We want our signal into the radio to cause the radio to pull out, the full power. So you'll have to look at your radio manuals, but in most cases, what we're talking about is setting the radio's meter to ALC, automatic level control, and then watching the ALC meter as we adjust the volume level going into the radio. On the Signalink, that would be the TX control. But if you're using just cables that you make, that you're talking about using Windows mixer and setting up the volume levels. When you're looking at the ALC meter on the Elecraft KX3, the manual says that you want about 5 bars of ALC deflection when you're transmitting. For the FT817, the manual says about three little indicators. So look at your manual and see what it says about setting up the proper transmission level. Now, this is the same thing you do if you were talking. The manual is going to talk about setting the mic gain. There might be a digital input gain control if you're using the data jack on the back. But just check out your manual to see what the optimal level is so that your radio is putting out a full signal and you're not just leaving some watts on the table. Okay, on the other side, if we're putting out too much signal to the radio, we could damage the radio if it's extreme. But even if we don't damage the radio, if we're putting out too much signal into the radio, our signal is going to be distorted. We might splatter the signal. We might be actually using more bandwidth. So if you're looking at like a PSK31 waterfall, our signal may actually go beyond the border of what a normal signal would be. So it's important not to transmit too much power into the radio, not to put too much audio into the radio. We might distort our signal and not be a very good citizen of the digital world. On the computer side, if we don't put enough audio into the computer, then only the strongest stations can be decoded. Stations that don't have a very strong signal are going to be too light to be decoded. So we want to make sure we have enough signal going into the computer. And our digital mode software typically has a little audio level indicator so that we can adjust. In this case with the Signalink, it's the RX button, the knob. We can adjust that and see this indicator go into the green and know that we've got enough signal that the computer's happy. If we go too far, the signal becomes clipped or distorted and our software may not be able to decode it properly. So setting these levels is very crucial to the success of doing digital modes. And with that, I'm going to end this video. So you've learned what digital is, in general terms how it works, that you need a computer, a radio, and some cabling, and that you can solve the cabling issue by just buying a Signalink box or a rig blaster and the appropriate cables for your radio. Look for my upcoming series of videos, in-depth videos about RTTY or radio teletype, PSK31, JT65, and Winlink. And with that, I thank you for watching.